Welcome back, learners. Now jumping on to our second concept, whereby we'll be looking at resistance and the factors that are affecting the resistance. So, firstly, a conductor is a substance that allows electricity to pass through. So for us to understand what a resistance is or what a resistor is, we need to start by looking at what a resistor is, or what a conductor is, because we're saying that a conductor is a substance that allows electricity to flow through it, right? Now, all conductors thus have a degree of resistance. So even though they are allowing the current or the electricity to flow through them, there is still some bit of resistance which they have. And then when that happens, when there's that resistance between the conductor and the electricity, that causes the conductors to heat up. Now, copper wires, those are mostly commonly used as electric connecting wires in circuits due to the outer electrons in copper atoms being free. Remember, when we're saying that those electrons in a copper atom, they are free, we are saying that they are delocalized. They are free to move wherever and however they want. They are not bound to anything in that outer layer of that atom. So that means they are free to easily move through the circuit, so they can be able to move around. Remember, once we connect the wire or the battery into the wire, the electrons are going to be moving from the negative terminal to the positive terminal. So this is only possible when we are using the copper, because those electrons that you find there, they are mostly freely to move around wherever and however they want. Now, copper wire is therefore has a low resistance. So that means its resistance to the flow of electricity is very low, which is why it is mostly used because of this property of it being or having a low resistance. So copper wire therefore has a low resistance and little energy is lost in the form of heat. Now, when an electric current flows through it, so remember we said, when there's a resistance between a conductor and the electricity or the current as it's flowing through, it causes the conductor to heat up. Now, because copper wire has a low resistance, now the heating up of that particular conductor is going to be low because of that low resistance. So that means none of the energy is going to be lost through heat. We are going to be conserving most of the energy within that particular conductor. However, other metals such as tungsten are used as filament in older types of light bulbs. They have a high resistance and do not allow charge to easily flow through them. So these old light bulbs, they were using tungsten as their filament, and that one had a high resistance, and as we are saying that, it did not allow a charge to easily flow through that particular resistor. So now, these metals allow only a small electric current to pass through, and they become very hot when connected in a circuit. Remember, once there's a resistance between the electricity flow and the conductor, that resistance is going to cause the conductor to heat up. Now, because these old light bulbs, they had a high resistance, that also means that even the heat generated is also going to be high, right? Now, as we are saying that they're going to become very hot when they are connected in a circuit. They do, however, have important applications, that is, in the provisioning of heat and light. So because now they provide heat or they generate a lot of heat, we can therefore say that they have some use. They were giving us heat, and especially in times of cold and in winter, we can like rely on them to generate that heat and also the light, because they do two things at once. They generate that heat and also generate the light that we need. Now, the resistance of an electric component is determined by its physical properties. So each resistor has, or each conductor has certain properties that is going to determine its resistance, and indicated on the component as a value in ohm. So the resistance is given or indicated in terms of ohm, and the symbol for ohm is the Greek symbol, the omega. So that is now the symbol for ohm. So in keeping with the resistors, we also need to remember that conductors with a very high resistance are called resistors still. And they are used to regulate the strength of the current in a circuit. Remember, the amount of resistor or the amount of resistance determine how much current is going to be able to pass through that. So because when we are using a higher resistance, that means the current passing through these higher resistors, it is going to be very low. So we can use the resistors to regulate how much current strength we want to pass through on each resistor. So if the current that flows through an appliance is too strong, it may damage the appliance or cause it to burn out. So if the current that is flowing through an appliance is too strong, that appliance can burn out. So therefore, which is why if the current is strong, we also then need a high resistor or an appliance that has a high resistance in order to control or to regulate that electric current that is flowing through that particular appliance. So appliances such as toasters, heaters, and kettles, they contain an element that heats up. So as we can see from this picture, the kettle has that element that heats up when there's a resistance between itself, the conductor, and the current flow through, and the resistance that is in there with the current flow that is flowing through that particular resistor. Same thing applies with the toaster. The conductor is going to now resist the flow of current as it wants to pass through, and then that resistance is going to cause that heat, and in this case, they can cause even the light on a toaster. So, a resistor made of nichrome wire, an alloy of nickel and chrome with a high resistance, is normally used in the element to convert electrical energy to thermal energy. Remember, thermal energy, that is your heat energy. So we are now going to, it is used to convert electrical energy to thermal energy so that it may perform a certain function. So the reason why we are using that particular resistor here on the kettle is because we want to heat up the substances inside the kettle, being water. So we want to heat up the water so we can use that particular resistor. So each resistor has its own properties, and because of those properties, we can then decide to use which resistor for which function. In a case of a kettle, we are going to use that one because there's going to be a heat being generated. However, in contrast, electric motors in appliances such as fans, the beaters, the washing machines, and tumble dryers contain a coil that has a low resistance wire, in which electrical energy is going to be converted to mechanical energy. Remember, mechanical energy, that's going to be our movement energy. That's the reason why our tumble dryers, they are drying and rotating, and our fans are rotating. So that electrical energy is converted to mechanical energy, our movement energy. So here, the movement of certain parts of the components of the appliances serves as a useful function. Remember, we have said the conductors, they have different amounts of resistance, and those resistance is going to determine as to where do we use those resistors, because each of those resistors, they have resistance. That resistance is going to generate a heat or generate a light, or in this case generate motion or movement. And because of that, we can then now be able to use different resistors in different functions. Then now, the resistance of materials can both be useful and also detrimental. So the resistance, it can be useful and sometimes be detrimental. It is very useful in controlling the strength of a current and in appliances where heat or light is employed functionally. So we're saying that it's useful because we can use that to control the strength of a current that we are using in appliances where heat or light is employed functionally. On the other hand, electrical power lines, the resistance hampers the transfer of electrical energy from one point to another due to much energy lost in the form of heat. So it is detrimental to us because now, remember, we need to transfer energy from one point to the other, and that energy is transferred through wires, and those wires have resistance. Now, because there's going to be a resistance between the conductor and the current flow, then heat is going to be generated. And generating heat in those wires means that we are losing the energy in a form of heat, and that means now the energy that we need may not be the energy that you're going to get eventually once that electricity gets to wherever it needs to get. So we can also use something called a rheostat. Now, a rheostat, it is a device that is adjustable. So basically, it's a resistor that can be adjusted in terms of how much resistance you want in that particular conductor. We can change that device to suit our needs. If you want a high resistance, we can just adjust that resistor. And then if you want a low resistance, we can also adjust that resistance. Now, looking at the factors that are affecting the resistance, there's 4 of them. Now, the resistance of any conductor, it is affected by the type of the material, also affected by the length of the conductor, also affected by the thickness of the conductor, and lastly, the temperature of the conductor. Now, looking at these factors individually now, starting with the type of a conductor, how does the type of a conductor affect the resistance? We have already seen that certain metals are better conductors of electricity than others. So that's now the type. For example, pure silver, copper, gold, and aluminum are the best conductors of electricity. In contrast, wolfram or tungsten and nichrome wire, those are poor conductors of electricity. So which then means semi-metals are poor conductors and non-metals except for graphite. Remember, graphite, that's now your carbon in a form of graphite. Those ones now, they are non-conductors of electricity except for our carbon in a form of graphite. Now, number 2, the length of the conductor. So the longer the conductor, the higher its resistance and the lower its conducting ability. So if we are using a longer wire, that simply means that we are increasing the resistance of that wire. And because of that, it is going to lower its conducting ability. So if you want a good conductor, use a shorter wire. So now another factor which is going to affect the resistance is the thickness of the conductor. So which then means the thicker the conductor, the higher its resistance and the lower its conducting ability. So if you're using a thicker wire, that thicker wire is going to have a high resistance, and because of that, there's going to be more energy being lost in the process of you transferring energy from one point to the other using a thicker wire. So the best one to use would be a thinner wire. Then the last factor which is affecting the resistance is the temperature of the conductor. So what we are saying with that is that the higher the temperature of a metal conductor, the higher its resistance and the lower its conducting ability. So if you are using a metal that has a high temperature or that is very hot, it is going to have a high resistance. And remember, the higher resistance means there's a lot of resistance between now the flow of current and the conductor, and because of that, more heat is going to be generated, and once you generate more heat, you are going to lose heat, and you're not going to get the amount of energy that you wanted initially. And because of that, that lowers that conductor's conducting ability. So, we have discussed the factors that are affecting our resistance. We have seen that we have different metals that can conduct electricity and some of them cannot be able to conduct electricity. We have also seen that whenever you are connecting a wire to a battery, whenever you're connecting a metal wire to a battery, the electrons on the outer layer of that particular wire will now start to move, because before they were delocalized, moving freely anywhere and however they want. However, once you start connecting the battery, they will be now starting to move in a certain direction from the negative terminal to the positive terminal. And because of that, electrical current is going to be generated. So I hope you learned as much as I did. And until I see you next time, goodbye.